Look at some of the sort of tools that we use, okay? So some tools you'll be super familiar with, like, SQL Profiler. Other tools you might not have seen before, such as Visual Studio Performance Analyzer and stuff like that. And then you guys are going to help me tune the application. So we're going to have a look at the application, run it through some tools, and try and get some suggestions on how to make it go faster. And we're going to see how many times faster we can make it go by the end of 1 hour, right? So let's see what we can do. So there's a link for where you can get hold of this, right? So it's just a web application for ordering actually DVDs. So it's like a very basic e-commerce application, okay? So let's actually go in and I'll show you the workload and a starting point. So I've got a VM here. It's running SQL Server 2012. It's running ASP.NET 4, and it's running the sample application. As you can see, no expense spared by actually Dell on this skin, right? The concept of a style sheet was completely lost on them, right? So it's just a functional application, okay? It's using ADO.NET to fire queries at the SQL Server. So when I log in, you can imagine there's going to be a query to have a customers table to retrieve it. If you go into the schema, you can see I've got a set of tables kind of like you'd see in a TPC, because we've got customers, orders, products, inventory tables, and so forth, okay? And it's got, it hasn't got a lot of volume. I think I've got about 100,000 orders in there and about 100,000 customers. So it's not huge scale. I'm mainly trying to get high volume through it. I'm not treating it as a VLDB or anything like that. So let's log into the application just so you can see what it does. Okay, so when I log in, it runs a query to retrieve all my previous purchases. There's a search screen, okay, so this will just be a SQL Server search, I would imagine. It's probably firing a query like select star from products where sort of category equals blah. And what it's also got is an implementation of the full text engine. Okay, so it'll retrieve all the movies that had a certain actor in them or something like that. I can click the movie I'm interested in, I go to shopping cart, I can check out, and then I can purchase. And as you can see, I get an order number. If I push F5, you'll see that I can reorder that to just check it's working there, right? So a basic workload, but you can see there's a couple of moving parts in there. I've got to search, I've got to audit, I've got to authenticate customers, I've probably got to verify credit cards, I've got stock control. So it may not be as complex sort of applications that you guys are used to working on, but you can see it's got the bones of what could be an atypical workload. So put yourself in a situation of a consultant. So you're called in by actually Dell, and they're like, okay, we want you to make our solution go faster. We're currently only processing about 200 orders per minute, and we need to be processing about 500,000 orders per minute. And you, Mr. SQL consultant, we need you to make it go faster. So there's a couple of tuning methodologies. So this is a large part of the type of work that we do. So the first tuning methodology is one that everyone uses. I call it the six-shooter approach, okay? And this involves really guessing what's going to make it go faster. And everybody does it because based on your experience, your bullets get more and more accurate, as we say. So, you know there's a guy called Jim who's working on the project. Check that procedure that Jim wrote, okay? Or flip it simple mode, full mode slower, man. Let's use .NET 4, let's add some RAM. Let's go to 64-bit. So this is what I call a six-shooter approach, because people are suggesting ideas based on their experience, but they haven't really fully gathered the evidence to actually implement them, right? And often you find experienced people actually have a lot of success with this. So it's very quick, because you suggest something, somebody tries it, and they come back and they're like, yeah, that's fantastic, it's working faster. More often than not, though, if you need something to go 100 times faster, it's probably not going to work for you. The next approach is what project managers love, and that's called the shotgun approach. That involves getting everyone in a room. So you get your hardware in the room, you get your developers in the room, you get your SQL Server people in the room, and you say, Nobody leaves the room until we have some suggestions. Everybody puts a pool of suggestions. The project manager ranks them and implements them all at once. This is a typical thing I see on projects because project managers like to run things like this. Let's gather the requirements, implement it in one hit, okay? It can work, but we don't particularly like this approach for more complex problems because even if you do make it faster, which of these solved your problem? You kind of don't know, right? So we do sometimes use it. For health checks, it's commonly used. Imagine you go on a customer site and they've got 100 things wrong, so you run a health check tool, it gives you a list of maybe 100 things. You sort of hand them all those things in one blast and they just go ahead and implement them. You don't care whether each individual one would or won't make a difference, but it's moving it closer to recommended practices. So we do sometimes use the shotgun approach. The hand grenade approach, everyone's probably seen this. Scrap the entire code base, it's complete crap, right? And let's just start from scratch again. We don't see this used too much because it's quite expensive. Often it's used for more political gain than so say for example, you wanted to write the project in Java and someone wrote it in .NET, you can be guaranteed every problem they have, the answer is going to be, should have written it in Java, right? So we don't tend to use that unless we're in where we use this project is if we take over a project halfway through and another company has written the project and there's lots and lots of problems. The reason why we would say we're probably going to start again is because if we take over that problem, we've inherited all of the legacy problems and we're now going to get blamed, right? So again, there's a political angle. So usually when I see a hand grenade, I'm looking for a political angle rather than a technical reason. Now, the approach that we're going to take here, and this is what we take when we're kind of trying to structurally make something go faster, is this approach. We might fire a shotgun of a health check, so just, is there any thing that's really obvious wrong? And then we're going to say, has it met its goals? We're going to define those goals, get some sort of baseline, measure the performance, measure exactly where it hurts. So we're going to use tools to isolate where it's hurting. Is it the application stack? Is it a resource like CPU? Or is it I/O? Is it contention? And if it's contention, what part of the application is having it? So we're going to find out exactly where it hurts, fix that bit, and then repeat that in a loop. And what you'll find is you're aiming for the easy fruit first. So what's going to give the biggest gain for the least impact? Typically, by the time you've done 3 cycles, you've got a very good performing application. So you've usually made enough gain to wrap up and walk out. But obviously it's a cyclic process. So that's what we're going to have a crack at implementing now. Starting off, so the first thing that we're going to do is just a quick health check, right? So there's a few tools that actually we use. So we land on a customer site and they're like, you've got 30 seconds to tell me if this is healthy, go, right? So we're going to use some sort of tools to try and find fairly obvious problems. So some of my favorites, SP Blitz, written by Brent Ozer, is pretty good because it'll give you output of very easy to find but common mistakes that you won't have time to look for everyone individually. It'll just give you an output of them all. You can also use tools in the .NET tier. So static code analysis will give you a quick look at the quality of the .NET code. You can also in Visual Studio run static code analysis on the actual database tier as well. So it'll tell you common things wrong with stored procedures. For example, have they opened a cursor but not closed it, use of select star, all common deviations from kind of recommended practices. It'll list them out for you so you can get a rough idea as to the quality of the workload. So let's just do that on our starting point. So I can go into here, I can type a new query, and in DS2 I can run my So this is a free tool that you can sort of download. So it'll give me a load of different tools a lot of the recommendations are operational. So we're mainly looking at performance, you know, so things like the backup and the security, not really too worried about. It's running on my laptop, so everything's going to be on a C drive anyway. I don't have a disk array in my laptop, right? So not too concerned about those sort of things. So, but then we come down to the performance section and we start to see things that we might be concerned with, right? So we might get the customer to fix those before we really started tuning, okay? So it's got file growth, it's set to %, so that's an indication they might be getting a lot of file growth events. High VLF count, so if they're getting problems with their write logs or problem inserting, we're probably going to get them to fix that, yeah? And some indexes have been disabled, okay, that doesn't sound good, right? So it's a good tool just to very quickly get an overview as to what's potentially going on. You can see that we've got a few other things. The max memory isn't set. Triggers on tables. So we now have a little bit of an insight into how it's written. So it's using triggers which may have side effects and so forth. Okay. In Visual Studio, just going to open up Visual Studio, I can go to the code base. So what it's got is, here's all the ASP.NET pages that were supplied as part of it. There's also a business layer. Now, I wrote that actually business layer, and what I did is I implemented 9 different ways of interacting with that. So I started off with the way it was originally written, and then I implemented a slightly different way and a slightly different way, and I put them all into the business logic there. And what you can do is you can right-click on the code, and you can run your code analysis. So what this is going to do is give you an output of common things that could be wrong with your code. Now, a word of warning. It's better to run the code analysis as you develop your solution, because if you wait until after you've written it and then run the code analysis, you end up with a lot of warnings which aren't really affecting the performance. For example, I didn't mark this at DLL as being compliant and so forth, but they're not really going to affect the performance. But you can see here these warnings are fairly useful. Where these are most valuable is to get the developers to correct the warnings as they go along. Now, what's new in Visual Studio is with the database project. So is everyone familiar with the SQL Server data tools? Yeah, good. So in Visual Studio now, you can use Visual Studio to effectively import a snapshot of your actual database, or you can develop your schema in Visual Studio, and exactly as I've done on the .NET code, you can do that static code analysis on your schema. So it's going to give you a list of common sort of database errors. Now, it's not an extensive, it's only got 20 or 30 rules. I'm hoping that Microsoft's going to eventually add kind of more rules in there, but there's enough that you'll get a flavor for fairly common problems that are going to be in the SQL Server schema. So that's some fairly basic tools. We do use things like the SQL Server Best Practice Analyzer as well. That's going to give you obvious configuration issues like, you know, max memory not set, tempdb not set to best practices. So these are all things that you should try and fix before you start your reproduction of the workload to really look at what the problem is. Okay. So if we're going to measure the performance, the first thing we need is to define the goals, right? Because we've been called in and they've said, well, it's currently doing maybe 200 orders per minute. We need you to make it faster. So the next question I would usually ask is, how much faster? Do you need it 5 times faster, 10 times faster, or 1,000 times faster, right? Because that's going to start to tell us how radical the changes are that we have to make. We also have different types of goals that we need to measure. So application throughput is the most typical thing that people are looking for, i.e. how many orders per minute can I get through my application is a common one, right? You might have performance goals. So someone might have a routine and the routine is too slow. So they've got a single stored procedure that takes maybe 30 seconds. They want it to run in 10 seconds. So that's not a throughput problem, that's a performance problem. Okay, so one is going to be measured in how many business transactions per second or per minute. The other is how many seconds it takes for a typical procedure or routine to run. They might have scalability goals. We want to be able to get 4,000 concurrent users on our website, okay? So we need to test the workload can hit that actually limit. As soon as it does, we're done, okay? Often we're given an optimization goal. So given this hardware, right, I want you to make it run as fast as we can on this hardware or on this particular configuration, okay? And then sometimes it's not so much making it faster, it's figuring out why it's going slow. So often you'll get a situation where we're on a customer site and it goes slow at 4 o'clock or something like that. And that's more troubleshooting than an optimizing one. So we're not really covering that scenario in this talk. We're more dealing with optimization. How can we make it go faster? How can we get more throughput? So imagine in this scenario, our end users come back and say, hey, I want 200. So they're looking at a 50-fold increase. That's quite a lot. The first thing we need to do is find out what tools we're going to use to generate a workload to test that we've hit. And what we have to do is bring back something to a test environment, a QA or a dev environment that reproduces and scales up the workload. Very common tool that we use, Visual Studio Load Test. Fantastic tool. Basically what you do is you fire up Visual Studio. If it's a web application, you get your end users to walk through the application, like they might log on, do a few searches, place a few orders. Visual Studio records that and it lets you parameterize that. You can then use Visual Studio Load Test to replay that on a number of threads. So you can say, well, take that workload and I want you to now simulate 1,000 users doing that. Okay? So you can start to test the scalability of your application by using Visual Studio. Now, in this example, Dell actually supply a custom test harness. So they actually give you an executable that you can run that simulates the workload for you. So we're lucky in this case, but if we didn't have this, it wouldn't be too much trouble to configure Visual Studio Load Test. That'll reproduce the workload, but after we reproduce the workload, we now need the tools to see what's going on. So from the SQL Server, our favorite tool that we use is SQLdiag, and this basically generates a trace file and perf counters. So I assume, obviously being a user group, most of you guys are probably going to be familiar with those two things. From the .NET point of view, we're going to use different tools, okay? Visual Studio Performance Studio is probably the most common one, and performance counters. So .NET emits performance counters, which by checking whether they're over certain limits, you can see if the application's healthy or not. The good news is, much like SQL Server, it's very hard to memorize every single performance counter. Like if I was to go around most of you guys and say, well, what's your top 5 performance counters and what sort of thresholds, right? Most people are probably going to come up with 5, what page life expectancy, compiles per second, right? But the problem is, how are you going to remember 20 or 30, right? So that's where the PAL tool comes in. So PAL, Performance Analysis of Logs, it's available on Codeplex, and what it does is it takes perfmon counters and runs a rules engine through it. And you can pick the rules engine for SQL Server, or the rules engine for Windows, or the rules engine for .NET applications. The good thing is, you can now start to get warnings for things that are wrong, even if you're not an expert in it. For example, I can run a SharePoint workload, capture the performance counters, run those performance counters through actually PAL, and I can start to get warnings for the SharePoint workload, even though I'm not a SharePoint consultant. Okay, so it's useful in that you're not going to be able to contain all the counters in your head, so it helps you flag out common warnings there. Okay, one of my favorite tools. Who's familiar with RML here? One. Okay, a few. Okay, excellent tool set for SQL workload analysis. My favorite tool set by far. I nearly cried when it didn't work initially in SQL 2012. if you haven't looked at it and you're doing workload analysis, I'd recommend having a look at it because it gives you a point and click interface and charts to tell you which queries or batches are consuming the most resources, and it's interactive, so you can drill down to where a particular problem is. So I'll show an example of that actually later on. Okay, so the first thing that we're going to do now is capture a baseline. So I'm going to my application, just say just how fast is my application. I'm going to reproduce at the workload and I'm going to capture some of the performance metrics, and we're going to have a look at what that means, right? So I'm going to capture a business benchmark, how many orders per minute, the SQL workload, okay, and I'm going to Visual Studio and we might look at the performance wizard and so forth. So let's actually do that, right? I've got my application. Dell gratefully shipped this little utility that I can get to. And what this does is this is going to simulate 10 users with no think time. So just 10 incredibly fast users, which is really probably the equivalent of 200 users, right? And they're going to be hammering orders on the website. So what I've got up here is I've got the common performance counters that we would typically look at, okay? So we usually look at this and then we capture the performance counters over time because we can put these performance counters through the palette tool to give us highlighted errors. Now, we can immediately see, looking at this workload, the sort of problems it's going to have, okay? Logins per second over 100, right? Who thinks that's healthy? You know, that's not healthy. So there's obviously something wrong there, right? We can see we don't have any problems on latches or locks, right? But if we look down here, we can immediately see a very common problem. Batch requests are 600, or well, they're up and down. Look at compilations per second. Okay, so that's not very healthy. And the good news is our application is instrumented. So our application, every time it places an order, it's actually emitting the orders per minute. Okay, so we actually know, and it's also emitting the average or the max response time. So how long does it take to place the order? So we know that our starting point is, we've got roughly, what's that, 650? 650 orders per minute, and response time 2,000 milliseconds, which sounds quite slow, right? Well, okay, it's 1.2 now, right? Now, as I run that workload, I've configured I've got a batch file here that will start the SQL diag. If you're not familiar with that SQL diag, it's a tool that ships as part of SQL Server, and there's an XML configuration file where you can tell it what performance counters to capture and what trace events to actually capture. So that's now capturing a trace. So now to see what's wrong, because it's a fairly small workload, I probably only need 30 seconds, because if it's 600 orders per minute, then in 30 seconds I'm going to get, like, you know, sort of 10 or 20 orders. So I'm going to stop that. And then the other tool I'm going to show you is one that you wouldn't have seen before unless you're familiar with Visual Studio. Just to prove for the audience, who here would say the largest SQL Server professional as opposed to a .NET professional? Okay, so I said, who would say they're sort of a .NET professional? Okay, so about a third SQL, about a third sort of .NET. And who is the rest of the third? As a both. Okay, both. Okay, so in Visual Studio, so I've got 2010, there's a performance wizard here, right? And I can start a profiling trace. Now, the one that I prefer is the instrumentation. It's going to measure the total time spent both in the application tier, and there's a thing called tiering where it'll also measure the time spent in SQL Server queries. So it go into ADO.NET, instrument it, capture the SQL that was sent and time that as well. And that's fantastically valuable, because how many times have you had a .NET application that takes 10 seconds and you've got to break that down into how much time was spent in SQL, how much time was spent in the app, how much time was spent in the mid-tier component, right? Well, this will do that for you automatically. If you've specifically got a CPU issue where the CPU on the app servers are running very hot, CPU sampling is best. Now notice it says recommended. Interesting enough, the Microsoft put that out as a recommended, but we don't tend to use that, because when we're dealing with databases, we're usually always worried about how long something took, right? We're not as concerned about the CPU on the app tier. So I usually start off with the instrumentation. So let's actually do that. Which projects, so notice I could have multiple projects. I could have a web project, a mid-tier component, and a business logic, say. Now, you don't have to have the source code either, because if you've got the debug version, you can actually link via IAS in to an ASP.NET application. But let's just enable tiering. I'm just going to run this for a little while. So what this is going to do now is it's going to spin up the debug version. It's going to instrument it, and it's going to capture the number of milliseconds that every single function call took. And anytime a call is made to the actual database, it's going to time how long that call took as well. Okay, so it'll take it a little while to spin up, and when it spins up, it'll launch the web browser so I can log in. Now, obviously, this is useful if you're doing the style of testing where you just want to test one interaction and see that, but we want to test the scalability. So what I'm going to do is leave that window open, go back to my test harness, and fire that again. So it's now going to fire what could be like 100 virtual users or so at that, and it's going to instrument that for me. Because now we can go in to see where our time is being spent, and we can start to see the sort of changes that we might want to make to this workload. There you go, so that's in. Now notice that the instrumentation is obviously slightly intrusive, because we're currently running at about 560 orders per minute, and without the instrumentation it was about 650, right? But it's still going to give us the flavor of what's actually going on. So I'm just going to run that for a little while. I'm going to stop that. I'm going to close the application, and now Visual Studio is going to recognize that the web app has stopped, okay, because I've closed the web browser. So it's to recognize that the process has exited. It's now going to analyze that, and it's going to give me a report that lets me. Okay, so it's the CPU. I can home in on a particular area. So this is when I kicked off the load. I can filter in on that area there. And if I scroll down there, it'll give me the hot path. So out of all the time, where did most of my time spent? So I now know that within the .NET application, 54% of the time was spent on this web page here, purchase. 25% of the time was spent on the login, and 19% of the time was spent on that. So this and this could be where I'd look to improve things first. If I go into the purchase, it'll now show me the function calls. The process request. I can see 54% of my time was spent on the purchase load event. So I go into there. There was a procedure called verify credit card. A developer has left a very naughty function in there. Right? He was obviously trying to simulate there, and he left a sleep function. Right? So you can see how we can find what's causing the time to go down, both from an application perspective, and if we go to the tiering, to the tier interactions, we can also see from the database perspective. So if I go down to the purchase, I can see that in the purchasing, I might need to highlight this here, there was 133,000 milliseconds, 133 seconds of that function being called. Out of that, only 8 seconds were within the SQL server. And there's a list of all the queries that were run. Okay? So that doesn't sound too bad. So actually, SQL Server was only, what, 7-8% of the workload there. So the problem for that one is in the application tier. Yeah? And we can see the problem in the application tier because we drill down the function. We can see a developer has made the application go to sleep for a while every now and then. Right? Other parts of the application, if we look at the login, we can see that most of the work on the login, so there's 44,000 milliseconds were spent at the SQL server, and 78,000 is the total execution time. So most of the work was spent at the SQL server side of things. So we now know to make this go faster, if we were to tune the queries on the purchase, it wouldn't make any difference at all because we made the SQL server faster. That's only 8% of the workload. But here, the SQL server is slowing down the logging function. And we can see all the queries that are fired, and we can see the average execution time is about 500 milliseconds. So we could take one of those queries. Now we can immediately have a heart attack because we can see that it's not parameterized, right? But we can see even a counter of that, it's still taking a long time. Okay, so those are the two big bets that we'd probably look to fix first. Like one, why is that query running slow? And then two, can we fix that within the .NET application? To fix that within the .NET application is going to be quite straightforward. If I go to my Solution Explorer, it's told me exactly where that was. It was in, where was it gone? It was in the purchase module there. Sorry, in the verify credit card, was it? And look at that. So you can see how it'll help us drill down to an individual line of code by using the tool set. We can then hand that back to the developers and say, hey, that's what's consuming all of the time. Be it at whatever grain we want to. This function is taking too long, or this individual line is taking too long. Now, on the SQL Server side of things, I've got my trace file. Okay, so I've copied the trace file. Hold on. To my laptop. And I'm just going to show you the RML tools, just in case you haven't seen that. So RML comes with this command called read trace. I've just put a batch file on it, read trace. And what that will do is it'll read a trace file, put it into a SQL Server table, aggregate it, it'll try and group up similar queries, and then it'll give you a reporting services front end on it. Okay, so I'm just going to run that. Now, unfortunately, this is SQL Server 2012, which isn't supported on the RML. The good news is, some excellent person wrote a PowerShell command that converts a SQL 2012 trace file into a SQL 2008 R2 trace file. He found out there's actually only one binary hex number at the start of the file, and if you change that, it's now the exact same as the 2008 R2 trace file. So I'm just going to run that to convert it to a so that's overwritten the header on the trace file, so it's now a 2008 R2. And then I'm going to use this read trace program. Read trace, I'm going to point it to the trace file. So that's going to read in all of the lines, it's going to aggregate them, index them, and then it's going to launch a reporting services front end that's going to graphically show me the workload. So we've seen from the Visual Studio analysis that we kind of know the query that was causing the problem anyway, right? So I wouldn't need to run it from the SQL Server side of things. I could have just copied that query into Management Studio, had a look at the plan to see if there's a problem with it. But I'll show you this tool because this is the main one that we would use, because when discussing with a customer where the problem is, as soon as we show them this chart, it becomes fairly obvious, right? This is what we need to fix, right? And then we can click on the workload. It will tell us all of the execution times, and more importantly, it'll tell us the query plan. So we go down to the plan. We can see that it's doing a clustered index scan, right? So it's as simple as missing an index, okay? So on our first cut, we're actually going to fix two things. One, obviously indexing, right? Now, this should be done at a basic level before you start making a lot of code changes, right? And then two, that code change in the .NET that we found using Visual Studio Performance Analyzer, okay? So we can see from the query it would need an index on username and password, yeah? So I go to the schema. Actually be faster to do it in the VM. So I look at the customers table and I'm going to add new indexes, and the index is already there. Okay, so someone has disabled the index. Remember when we ran the Blitz tool? And it said, hey, there's some indexes that are disabled. Well, that's actually one of the problems we've actually got here. In 2008 R2, the GUI doesn't tell you if the index is disabled, which is really annoying, but in 2012 it actually gives you that. So what I can do is I can just rebuild that index to re-enable it. There you go. So I've now got that index working. I've changed the .NET code. So I've just made some minor changes on there. And now I'm going to re-baseline it before we do that. So let's just recap the sort of information that we can get. Oh yeah, the other thing that I didn't show you, I might just show you the other thing, is dynamic management views. We would commonly run these as well. The weight stats, which hopefully everyone's familiar with. Now, where we've got to be careful about the weight stats is the weight stats will only show us what's slowing down SQL Server. As you saw, the problem might not be in the data tier, the problem could be in the application tier. So if we focus too much on the weight stats, we can miss how we make the solution as a whole faster, but it's still useful. So we can see here that 25% of the time is spent on this preemptive OS delete security context. Anyone know what that weight stat is? No, but it's close. It's not a trick question. I don't know what that weight stat is. It's not a documented, it's an undocumented weight stat. But we know it's a preemptive, so that means something outside of the SQL Server at the kernel level. In 2008 R2, there were about 100 of these preemptive weight stats brought in, but they weren't terribly well actually documented. So we've got an undocumented. If you were to Google that, you wouldn't get too many hits on what that means, right? But actually, I do know what causes that because as we step through, you'll see at what point it goes away, right? But it's not terribly well documented. Okay, so, but you're on the right actually track anyway, because it's authenticated, because it's a security context. It's probably going to be related to authentication, either logging in or out. Yeah. So let's get a recap on some of the stuff that we saw. We saw the tiering. That's a lovely function in Visual Studio that lets us see the holistic view between the data and the application. So no more one team kind of pointing the finger out at the other team. Now we can get one report to see where the time is being spent, regardless of what actually tier it's in. 2, we can see from the RML what our prime candidates are just for making the DB engine workload go faster. Okay? We can see from the weight stats if there's anything obvious run, right? Now, because this is an OLTP workload, what is the weight stat that we ultimately want to see in an OLTP workload? Anyone? When you've tuned the hell out of an LTP, you should just be left with one. And there's one unsurmountable weight stat. Sorry? Yeah, okay, I'll give you. Can't go any further than latches, yes. Often one that you hit before latches, until Fusion IO came along. So ultimately, write log, okay? Because your log generation rate is going to be the ultimate limit. Even if you get around latches, you're still going to be, so people have got weird and wonderful patterns to try and get around latching, like, you know, hash partitioning and stuff like that. Even if you get that, you're going to eventually hit an IO limit on your log bottleneck. And even with things like Fusion IO, they've only been able to go up to a certain speed on the log rate. So that's going to be it. So if we hit our write log, our logical tuning is more or less complete, because that means we have to throw hardware at it in order to get rid of the write log. Now, as it happens here, we don't see any write logs and we don't see any latches. So we're a long, long, long way away from being an optimally tuned workload. Okay? We can also find out from the exec request DMV queries that are currently running and why they were blocked. Okay? So we can see here that when we run this, not too many queries were blocked. In fact, I didn't show you the CPU, but the CPU on the SQL Server was only running at about 10%. So there wasn't really a query problem. So let's rebase that now. And I obviously showed you how to find the time allocation. So what I'm going to do is I'm going to re-go to that, and let's rerun that baseline now. Oh. Let's go back to our instrumentation. Hey, so we're up to 1,000. Just at the bottom of the screen there, you can see the. Okay, so that's not too bad. So I don't know how far it's going to go up to. The first change, well, there's a bit of indexing and a bit of obvious code fixes. We're up to 1,700. And more importantly, our response time has come down to about half a second, right? So that's actually not bad. It's still a long way away from our 200,000 orders per minute or whatever that our customers wanting. So where to find out what to tune actually next, right? So I'm not going to go through the whole process of running the Visual Studio Performance Analyzer because it takes the time to actually capture. So what I've done is I've saved a screenshot and I'll show you some, let's just clear the weight stats and show you some of the DMVs that we could use to help us see what to do next. All right, so we're still getting that preemptive security thing as a number one issue. We go to the exec requests. Now this is a very telling thing here because we've got 10 threads hammering away. How many queries should we see in our exec requests? 10, right? Or 9, but we're only seeing 1 or 2. So that means the queries aren't getting to the DB engine, okay? So still don't have any latching problems. So we got parameterization problem. Anyone hazard a guess as to what we could do to make it go faster now? Yep. Yep. Yeah. So you guys are good. I have to offer you a job. So logins per second, all right? So if we were to run this through PAL, and I'm just going to show you the PAL output, as you saw, when I did my SQL diag, I got a BLG file, yeah? Just to show you what that looks like. Now, the problem with a BLG file is if you open it up, it's just, you know, it's meaningless. It's just hundreds and hundreds of counters over time. So, I don't know if you guys have ever used the PAL tool. Who's used a PAL tool here? Right, so actually a few people. So for those of you that haven't used PAL, it's definitely, if you're working with performance counters, it's a useful tool. What you do is you point it to your counter log that you want it, and then you give it a threshold file. And some very nice guys have put their IP into these threshold files, and you can actually edit these to add your own rules as well. So we've put a load of counters in there for SQL Server, so it adds a little bit more than what you get out of the box. But even out of the box, there's a fair few rules, and there's one for ASP.NET as well, so you can look at the application tier as well as the database tier. So I ran it earlier, and what it gives you as an output is it'll give you a web page output where it'll show you how many warnings it found based on the rule set. So if we go to this time period, we can see that it had 12 alerts, and interesting enough, it didn't put the logins in there, but we can see that it's warning us about the high number of compiles per second. It's given a warning about that, but it'll also give you a look at the counters as well. So we should get, it didn't capture logins per second, I don't think. So that's one of the rules that should really be adding. Logins per second, as a rule of thumb, should never be over about 1 or 2, right? Because if you've got connection pooling working for you, you shouldn't get that number of logins. To definitely know that you've got a login problem, if you profile the application, let me just show you this. Okay, so it's still running its load test, it's still hammering away. If I run SQL Server profile, on the login event, there's a column that you can add called event subclass. So if you, for example, you might have an application and you don't know whether it's properly using pooling or not. If you just capture some of the workload, look at the login event, there's a login event, you'll see the event subclass tells you whether it's pooled or non-pooled. Okay, so I now know I definitely don't. Now in .NET you generally don't have this problem, but in Java applications obviously that doesn't support connection pooling out of the box. So the developer has to use a custom library to get pooling to work, to get some form of pooling working. So let's just fix that. So if I go to my application, I'm going to stop that. Now, what we should see as well, if we had looked at, and I think we did look at this just to show you that, just go back to the, if we'd have gone into the application tier, we'd have see this open connection taking a long time. So from Visual Studio, you can also determine you've got a pooling problem. So I'll just show you that in the, on the next one. Yeah, here we go. There. So if we'd have done a Visual Studio profile and gone to where all the time's being spent, we'd have seen that in the functions, 44% of the time is being spent on this open connection. And if we drill into that, we can see it be a SQL client open in the connection. And that's a second sign that there's a pooling issue. Okay, obviously easy to fix. Or so you'd think. Where's pooling? Pooling. True. So we can fix that and we can rerun. Now, one of two things that will happen. It'll either run fantastically fast now, or the other thing that'll happen is, why do you think they turned off connection pooling in the first place? So anytime you find that a customer's changed a setting, often they've changed it because of a reason, and when you change it back again, you end up finding out that reason, right? So we're in danger of that happening here. Now, as it happens, it's still. So let's just go back to our. Okay, no, that's working away. Okay, so that's actually okay. In the original demo, one of the pages had forgotten to close a connection, so they had a connection leak. So what happened is, instead of finding the leaky connection, they turned off connection pooling. So, but what can happen is, as you improve these things, you suddenly find these actually bugs happen that should have been fixed earlier, and you now have to go in there. Does anyone want me to show you how to find a connection leak? If you have a connection leak in your .NET application, does everyone know how to find those? No? Okay, so let's introduce the connection leak, right? So what I'm going to do is I'm going to go to the code, and I'm going to manually, now, you'd have to close your eyes so you don't see where I'm going to put it, right? Because I'm going to try and trace it. So I'm just going to go to the login page, right? And I'm going to go to the bit that closes the connection, and I'm going to comment that out. Now, how would we find, so the question is, how would we find that if we didn't know? Now what you see is, look at the user connections there. So that was at 16. I've only got 10. It's now gone up to 56. And I'm just going to lower the, yeah, bang. So I've now got an error in my application, and the error is going to say something like, connection pool limit reached, blah, 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 right? Now, as it happens, it's just a driver program, so it's not going to give me the actual error, but we pretty much know. So first of all, how do you spot it? Well, you'll see the number of user connections obviously going up, yeah? The other thing you'll see, if I just rerun that, you can add the SQL client performance counters to here as well. So if I go to the .NET data provider for SQL Server, get there before it crashes. Here we go. You see the number of pooled connections will gradually increase. Now what will happen is it'll actually allow a lot more than 100 connections, even though 100 is the default, because there's a thread in .NET that tries to reclaim them. So as you leave them open, .NET will actually close them for you, but that's only one thread. So obviously that falls further and further behind until eventually it craps out. So we can actually see it's working for longer than you think because the number of reclaimed connections. So this single thread is desperately trying to close all the connections, and eventually it's going to hit that 100 limit, bang, and then it's going to bomb out. So how would we spot this? Well, the best way to spot this is by looking at the connections. Because if we look at the connections, we know there's only 10 proper connections, but we know there's 206. So 190 of these have got to be dud ones, right? So what we find is on the dud ones, the very last column tells us the most recent SQL handle. So what we can do is I can cross-apply that to get the text. And what you'll find is you've then got to spot the pattern of what the most common query is in your stacks. That's obviously going to be this one. Okay, so that's probably a unique string. And then what you can do is go looking in your, now depending, what you've then got to do is either, if they're using stored procedures, you've got to search in the DB engine to find that stored procedure name and then find the piece of code that called that stored procedure and then trace there to find the where it should have closed it. Because we're not using stored procedures, it's just in line, I can just search within the code. There you go. So I can see there's a function called actually login, yeah? So I could search for where we're calling the logging function. Now, here you go, so I'm at the login page, and we should eventually see a function call to the login. Where's it gone? There you go, there. So now I read from here, so I can see I've got a connection, I'm opening a data reader, so I'm going to scroll down, see where I'm consuming it. I'm consuming it, and when I finish with my data reader, I'm closing it, and I'm obviously not closing the connection there. So that's how you find a connection leak. Obviously, if I change the behavior of the reader to close when the reader was closed, it wouldn't have had that problem in the first place, right? But you can use that to at least trace it down to an individual page or an individual part of the .NET application. Because one of the problems is if you've got a website with hundreds of pages, finding without having a way to trace it back can be very hard. Okay, so that's how to find and close in your application a connection leak. Now, the next thing. Yeah, so we've added connection pooling. So let's see how much faster we are with the connection pooling. Oh. Did I compile it? I think I did. Yep.
For me, is rather, maybe I get that. So you're only closing the connection. I just thought that you're actually supposed to dispose, for example, using it. Because even if you just close them, you'll have to start the garbage collection to actually remove it.
So in the .NET 4, the close and the disposers are interrelated. So a close should dispose of it in .NET 4, but you're absolutely right. The correct way of implementing is by implementing using, and we're actually going to have a look at that actually later on. So the way it's using its connection there is a little bit dodgy. But just as closing it should dispose of it, but the recommendation is to put it inside a using, because that's going to automatically dispose of it as well. So we're at 2,500 there, so you know that's a bit more of an increase. Now have a look at the wait stats. Let's just look at our wait stats. I'm just going to clear it and then run it again. Hey, so that weird preemptive authentication thing, although I couldn't find much information on it, is obviously a result of connection pooling. So it's part of the authentication or the log off process. SQL logins. So now that's an important point actually. If you're building a very large application, we sometimes recommend to avoid Windows logins when you're using connection pooling. Anyone know why? No? So the reason is the client creates one pool per process per authentication, which means if you're using Windows identities per identity. So if you've got 10,000 users, you'll end up with 10,000 individual application pools. So depending on your type of application, the worst application that gets hit by this is something like an intranet application that's grown slightly larger, where every user has their identity flow through to the SQL server. So where it's using a delegation, because you get a separate pool per user, and that means you don't get any pools really, unless the same user comes back. So what you need to do then is to either switch to use a trusted model where there's a Windows identity for the ASP.NET, an identity doesn't flow, or you have to switch to use SQL authentication. So you can run into scalability issues with Windows authentication. But on most applications, it doesn't matter. But it does mean that if you go into your typical application with 100 users, and they're like, yeah, we're using connection pooling, different users' connections probably won't be pooled if they're using Windows.
How can you spot that? Because they'll all be tagged as pool.
The way that you'll spot that is if you go to the .NET data provider for SQL, the number of pools. Yeah, it's quite hard to spot though, yeah. Because from the server end, it can be super hard to spot, yeah, because it's still going to come in as a pooled, yeah. So from the profiler trace, it's like, yep, this is a pooled connection, this is a pooled connection. But of course, each one is taking that extra seconds. So unless the same user is coming back, obviously that is being pulled. But if different users, they're not going to share that same connection. So that's a problem. Now, obviously, for small applications, we don't care. But as you scale up, you can run into that problem.
It's worse than running without pooling, right? Because you have extra pooling overhead.
Not necessarily, because it depends on the chattiness, because if the same user is continually opening and closing the connection a lot, so it depends on the chattiness. If the same user is opening and closing a lot, he can get benefit from the reset of the connection. So it's still worth having, I think. But if it's sort of application where users only, so if it's a win form application where users only connecting once and he's doing a bucket load of work and he's going away and he's not coming back again, then yeah, you'd be better off with a hard connection then. Yeah. Okay, so let's look at what. Yeah.
Just to make sure I understand it, what you're saying is if you have a large Swedish application with lots of users, what you want is you don't want everyone to have a login. The user sitting here, this has got an on login all the way down to the server. What you want is the application, the middle tier has got to have one single login which is users to the server, and then the middle tier authenticates.
Yes.
The user.
Yes, until you then hit the other limit, right? Which is if you just have one account, right? The max pool by default is 100. So after you get 100 connections, it bombs out. So often your application tier needs a number of 2, 3, or 4. Now, as it happens, that usually isn't a problem because if you've got multiple application servers, well, each individual server is going to be a separate process, so that's going to be an individual pool. Sometimes I've actually seen people have to use a position where in their mid-tier they round robin authentication, so they have 3 SQL accounts and they use a different one, or they use a different connection string. So if you change something as simple as the application name, part of that will then automatically create a new pool for you.
Really stupid question.
Yeah.
Why not increase the connection pool?
Yeah. So, well, what you would do is you would increase it. Yeah, sure, up from 100 to 1,000, right? But there comes a limit at which you might want to have multiple pools rather than just one monolithically huge pool. But if, say, for example, your sort of target application wanted to maybe go up to 500, then yes, absolutely. Say, for example, your target workload wanted to go up to 50,000. Well, I know that's a lot, right? But there will come a point where you might want to, by design, have a few pool groups rather than just one kind of monolithic group. Now, for most applications, that's not a problem. But as you start to get to the larger scale applications, you can see you've got a choice. If you use Windows identity flowing, you're going to have lots of pools. If you just use one account, you're going to have one kind of massive pool. And the choice you have is, do you go in the middle? You know, it's your call. Does that make sense? Yeah? Okay, so I'm going to save you the bother, right? So we've now got a situation where we're tearing along at 2,600 orders per minute, right? So about 5 or 6 times faster. We now look at our wait stats, right? Our wait stats, async network I/O. Who knows? Well, that's a common thing. Anyone hazard a guess as to how we're going to try and fix that? What's that?
Store blocks? Instead of sending the...
Okay. Yes. Okay. You're kind of yeah. So you're thinking it could be, and that's something else which is quite interesting. If you look at the workload, it's what we call a chatty workload. What I mean by chatty is a high volume of small SQL Server statements coming down between the client and the server. Now, because it's all running on one box, that's not too bad. If this was SQL Azure and you were crossing a larger network boundary, this would kill you, right? It would absolutely kill you because your round trip between your application and your kind of database. But as it's all on one server currently, it's probably using a shared memory provider. So the overhead of that probably isn't that much. But yeah, anyone? Okay, Erlong's going to know, aren't you? Async network I/O.
Yeah, well, basically, fix the client. Fix the client. It's something that's outside this server. It's out of the network for the client.
Yeah. So by far, the most common cause that we see of async network I/O, and we wish they would change this actually error message, because you see that wait state and you immediately think it's a network issue, right? Because you're like async network I/O, so you start kind of looking at network bandwidth and looking at the utilization and the latency. It's usually got nothing to do with the network at all. Usually it's what we call back pressure. So what this means is the application tier has started to consume a result set, so it could be 1,000 rows. It's consuming them, and then it's gone off to do something else, right? It's gone off to run some .NET code, and so it's had to tell basically SQL Server to stop. And at that point, SQL Server will slap an async network I/O on because it can't continue to spool the result set to the client, right? It's very bad because you're tying up threads within your SQL Server. So your SQL Server running is a limited number of threads it's got, and now it's had to stop that. It's going to have to offload it from the stack, and it's going to have to put another one on, right? So very inefficient. The problem is, how do we find this, right? Because we've got to find the part of the application to fix, right? So this. Super bad way of implementing paging. The worst case I saw with this by far is actually an e-commerce application. Whoops. And what they did in an e-commerce application is they started a transaction with a begin train. Ooh, I was lucky. So they started a conversation with a begin train, started inserting the first part of the transaction, and then they went away to make a web service call to verify the credit card number, and that could take it up to a second. So there was an async network I/O for this entire time. So let's look at how we'd find that, right? So we go in, our workload is still running, and what we would do is go into the exec request here, right? Go with that SU1 up there. Go with that connections one. I'm not going to find my. Now this is interesting because when we look at the wait stats from here, I'm just going to clear that just so it's fresh, right? It's like, yep, my biggest problem is async network I/O. But when we run the exec, we don't find a single query that's waiting for there. Now, if you ran this enough, we'd hopefully eventually find one of the suckers, right? Come on, will we even find one? Nope, so we might not even find one. So what you'd have to do is to, there's something called DMV stats where you can frequently run that. What this is called, if we look at the application, something that I absolutely hate, and we're hoping we can actually, well, I'd like it to be eliminated. There's a technology you're probably familiar with called Mars. And this causes a lot of async network I/O as well, but it's quite hard to spot. So what will happen is it'll pause one query while it goes away to run a second query. So it's a way of getting multiple queries to share a connection, okay? Generally a bad idea, right? If you have one query which is running and you want to run another query, why didn't you just use a join in the first place, right? So I haven't yet seen a design pattern that a customer has given me for using Mars that couldn't be rewritten to not use Mars, right? There's usually always a way to use something like a data table, spool through the rows of a data table to do the second lookup if you need to. There's usually some way of getting rid of it. So I'm going to disable that. Sorry? Yes, yes. So that's one of the problems is we've got to make sure that we eliminate that at your use now, and it means writing better SQL basically, using joins or not using it like that. Yep. Yeah, that's a quarter past. Yeah, that's fine now. So we break now.